The autopoiesis term, from ancient Greek auto standing for self and poiesis for creation, refers to a system which continuously redefine themselves by inward supporting and reproducing themselves. With the mimesis term, standing for imitation, we intend to describe the imitation of the real world and nature, which is, according to classical aesthetics, the theoretical structure of the artistic creation. These two terms are somewhat opposite and allude to two different approaches that the designer would face in the creative process. If the former focuses on the inside, subordinating the strictly formal demands to the categories of utility and efficiency, the latter rather refers to the outside of the project, searching for a formal justification, for example the geometry, and a sort of replication of the natural model. Omitting the misleading of philosophical implication, is it possible to think today about an actual point of convergence between the design and the structural verification phases? About the moment of the creation of the architectural shape as an harmonic synthesis of formal intuition and dynamic selection of the parametric requirements? Today, parallel structural architecture and engineering research is taking this direction, focusing on methods which are based on objective elements and the determination of parameters that are not necessarily homogeneous. Here we have some examples of parametric and algorithmic researches. Michael Ansmeyer's studies on health system and computational architecture explored the use of nature's growth processes as generators of the architectural design. Theo Janssen's creepy models called kinetic sculpture, a sort of mechanical creatures made of plastic tubes, able to move on the wind and walk by their own. These fascinating structures are the result of parametric thinking at its best. Asymptote's Strata Tower, due in completion next year in Abu Dhabi. The Strata Tower's innovative exoskeleton structure was created using advanced parametric modeling tools and techniques from the beginning of the design process to the production phase. An extensive use of mathematical algorithms is made by the engineer Cecil Balmont from the international firm Arup. He creates very flexible structural patterns with a high level of prefabrication and industrialization. His collaboration with the architects Toyo Ito and Alvaro Siza are good examples of these researches. The development of CAD/CAM software offers nowadays a range of formal solutions which can support the designer in this challenge with many updated tools. Alongside the traditional processes of shape creation, it may be useful to adopt some numerical methods commonly used in genetic algorithms. Genetic algorithms are a class of adaptive heuristic search algorithms premised on the evolutionary ideas of natural selection and genetics. The basic concept of GAs is designed to simulate processes in natural systems necessary for evolution, specifically those that follow the principle first laid down by Charles Darwin of survival of the fittest. As such, they represent an intelligent exploitation of a random search within a defined search space to solve a problem. Appropriate use of these models applied to the problem of finding new shapes can return an ethics value to the need for a nonlinear space definition of the contemporary architect. To this end, a special mention is devoted to the work of the group Kokuja, which widely exploit the potentiality of reproducing natural shape using genetic algorithms. In this scenario, it is clear that an uncritical use of 3D modeling software, which allows anyone to create beautiful surfaces and complex nonlinear geometries, can only fuel the distance between the figurative intent and the tectonic coherence of the architectural project. Rely upon software to define the spatial configuration of a project of architecture does not necessarily mean to give up the direct control of the designer at every single stage of the compositive process. All the examples analyzed show us how it is fundamental to achieve a deep knowledge of the multiple options offered by the IT industry in the CAD/CAM field as an essential technical scientific cognition of the contemporary architect. It's quite interesting, for example, to note that how Sasaki's research on structural optimal form, following different approaches and paths, has led to different architectural outcomes, strictly depending on the interaction established with different architects. The paradigmatic example of the Qatar Education City tree-like structure configures some crucial key issues. Can the traditional dichotomy between the architectural project and the structural project be solved not only preserving the original design shape of the final form, but also allowing the definition and employment of new proper constructive technologies? The goal is to unify the compositive process in a completely redefined operational context in the attempt to overcome this old-age dichotomy. In such a way, a critical use of structural optimization algorithms can be adopted to ensure both the correspondence between shape and structure, and between design and construction. Thank you for your attention.